So for 4, 4, we start with, it's trig of any angle. We start with let -3, 4 be on the terminal side of theta. So this is telling us the ordered pair. So you know we have a circle, passes through 3, 4. That's the terminal side. We're going to find the sine, cosine, and tangent of theta. So if that's the terminal side, it started at 0, 0, it rotated around to here. If we were going to graph 3, 4, we would start at 0, 0, we would go to the left 3, and then we would go up 4, which would form a right triangle. That tells us our theta in the right triangle is what connects the terminal side to the x-axis. That is our reference angle, but I do not know what it is right this moment. I mean, we can figure it out, but I'm not going to. Don't need to. Okay? We're just going to find the sine at that theta, the cosine, and the tangent at that theta. So the sine is y over r. I do not know if this is a unit circle yet. Is it a unit circle? Bless you. Is it a unit circle? No. Why? What's the radius? 5. Oh, yeah, it's 3, 4, 5. So this is not the unit circle, so I would use y over r instead of just y. Or I could change it into the unit circle because the triangles would be similar triangles. So it's kind of up to you if you want to change it into the unit circle or not. But I'm just going to leave it as y over r. And that would tell me my sine is 4/5. My cosine would be x over r, sorry. What would, x over r, which would be -3/5. And my tangent is -4/3. I would not say 4 over -3. If you said 4 over -3, you'd miss some credit because we never leave a negative in the denominator. We always reduce. So -4/3. Given tangent of theta equals -5/4, and the cosine is greater than 0, find the sine and the secant. The tangent is -5/4. I know that the tangent of theta is always y over r. So what ordered pair gives us tangent at -5/4? Oh, it's totally y over x. I don't know why we're y over r. Sorry. I mean, I was just making sure that you were paying attention. Good job. Good job, Kylie. Now back to my question. What is the ordered pair that gives us -5/4? Ooh. -4 or 5? Or is it 4 -5? We use the second piece of information. Cosine has to be greater than 0. And what do we know about cosine? It's x, so which is the ordered pair I should use? Winner, winner, right there. So we've got 4, -5, somewhere down here. Is this the unit circle? Is this on the unit circle? Is the radius 1? No. Is the radius 3? No. Why is the radius not 3, 4, 5? Why is the radius not 3? It has to be the longest side. So how do we find the radius? Pythagorean theorem. 4 squared plus 5 squared. So 16 plus 25. Is it square root 41? Yeah. And our theta, remember, if you're not quite sure about the theta, the way that you graph it, you go x, then y, you come back. That makes our theta right there at the x-axis and the terminal side. So we're doing the sine of theta. The sine is -5 over square root 41. Am I going to leave it that way? Am I going to leave it that way? No. We have to rationalize. Just rationalize by multiply the square root of 41 over the square root of 41. So we get -5 square root 41 over 41. Secant. So cosine, I don't know what secant is, but cosine is x over r. So that must mean that secant is r over x. So r is square root 41, and x is 4. And again, it didn't matter what measurement theta is. It mattered that I had the side lengths. Find the sine function at the 4 quadrant angles. So these are called quadrantals. Or quadrant angles. And it kind of sounds weird because it calls it a quadrant angle, but it's not in a quadrant. Quadrantals are on the axes. At 0, at pi over 2, at pi, at 3 pi over 2. They're the ones on the axes. On 4-2? Yeah, it's the same thing. I just didn't tell you the name yet. So we're going to need, for 0, we'll need the ordered pair, 1, 0. At 0, or at pi over 2, we'll need 0, 1. At pi, we need -1, 0. And at 3 of pi over 2, 0, -1. So what's the sine of 0? 0. What's the sine of pi over 2? 1. What's the sine of pi? 0. What's the sine of 3 pi over 2? -1. That was so fun. Let's do it again. What's the sine at 2 pi? What's the sine at 5 pi over 2? Sine at 5 pi over 2? It's 1. What's the sine at 3 pi? 0. What's the sine at 7 pi over 2? I'm not skipping anything. I'm like, thank you. I'm not skipping any of the quadrantals. I'm just going around again. What's the sine at 4 pi? What's the next one? Sine at 9 pi over 2. Sine at 5 pi. And then sine at 11 pi over 2. Do we see something repeating? When it repeats over and over again, that's called a period. Because it has cycles. It happens regularly. Over and over and over again. But for real, the period of sine would be how long it goes around once before it starts repeating again. The period of sine is how long in angles. What's one period of sine? One complete cycle of sine. I heard a noise over here, but I'm not quite sure what it was. It was like quieter than them out there. Well, what's one complete cycle? We not understand what I'm saying? Oh, you're saying 360? Yeah, so I'm talking in radians here. 2 pi. So the period is 2 pi. It repeats the process over and over and over again. That's why it's called a period. But more about that later. Last thing is, we already talked about reference angles. We're just going to do some examples that are just literally just reference angles. Some of them are in degrees, some of them are in radians. You do not switch between the two. You stay in the form that it gives you. So question A is 300 degrees. My answer will be in degrees. So where is 300 degrees? About here. The reference angle is if I went X, Y, and I graphed that point, the reference angle always connects the x-axis and the terminal side. What degrees would that reference angle be? 60 degrees. B, negative 135. The reference angle connects the x-axis and the terminal side. What would this reference angle be? 45. We do not say negative 45, even though I would be going in a negative direction. The reference angle is never a negative number. It's part of a triangle that I would form. 2.3. What form is that? Radians, because there's no degree symbol. So 2.3. This is 0 and 6.28. This is 3.14. 1.57. That doesn't really look like a 5.7. Sorry, that was really messy. Okay, 1.57. 2.3 would be about here. I don't know. You're almost 30? I don't even know she heard me. How do we find out? You're almost 30? Oh my gosh, you're so old. I could hear the whole conversation, how you wanted to be smaller, how they talked about the complete opposite. Okay, sorry. We just have 3 more examples. How do we get this? So I'm not going to use 3.14 because that's an approximation. Let's give me a better. I'm going to subtract pi minus 2.3. Now, really, the most accurate answer would be pi minus 2.3. That would be the most accurate reference angle. But if we actually found a rounded answer, approximately 0.8416. Kind of just depends on what the direction said. All right, 2 more. We've got negative 6 pi over 7. So this is not one I'm familiar with. But if we have pi divided by some number, that just tells me to take half of it, divide it into 7 equal places. We're going to pass through 6 of them. The negative tells me I'm going down. So I'm going to divide the down part into like 7 equal places, somewhat. There you go, 7 places. Those are equal spaced. And we are going to pass through 6 of them. So what reference angle do I have? Just 1 more pi over 7 to get me to the x-axis. And another not familiar breakdown of pi, 8s. Done 4s. I'm going to pass through 5 of these. 1, 2, 3, 4, 5 of them. The reference angle is what takes me to the x-axis in the shortest way possible. What's my reference angle for this one? Sorry, I did not understand what you guys said.
3 pi.
Yeah, 3 pi over 8. Good job. All right, so that's all we're going to do today. There is more 4-4 that we will do next class, but you will notice there's actually 4 assignments, but I don't know, if you know your unit circle, they're not going to take that long. But there's like 4 assignments. So I'm going to stop talking. You guys have over 30 minutes left in class today. And then if you have questions about the previous assignment, I can do questions. If nobody's asking me questions, I can go back to doing conferences. Yes, there's 2 4-4 assignments and 2 4-2 assignments, right? Yes. So there's 4 total. But that's only, like, I could have made it 1 and just made the assignment like 4 pages long, but it's just how I had them saved. They're saved into different things.
Can I go get my Chromebook charger? It's in my locker.
Yes, let me write you past your locker. Okay. I know it sounds like a lot, but I promise you, if you know the sign of 30 degrees, a lot of this isn't going to take as long as you think. So pick one that you feel like starting on, and or ask me questions. L-I-E or E-I?
L-E-I.
Oh my gosh, why am I writing you this pass? It's wrong pass. Here you go.
Thank you.
Yes, so there's 278. There is a worksheet for 4-2. There are 2 worksheets for 4-4. Not 3 of them, 2 of them. There's actually 3 of them, but only 2 of them for now. The 3rd one comes when we finish the notes. Do you have a half hour in class, which we never even have that much time in class? And like I said, some of these won't take that long. Believe me, I've done them all. Like, what's the one I was looking at before? I don't even know where it went. Never mind. And if you have questions on that other assignment that is due today,